それでは時間になりましたので、セッションを開始させていただきます。これからのセッションは、マグダ・ストーゼクさんによるプロパティベースドテスティング、テストライブラリにやらせようです。どうぞ。
Hello, thank you. My name is Magda. I'm a Scala developer at Software Mill, and I'm very happy to be able to be here today in amazing Tokyo and be able to talk to you about one of my favorite subjects, property-based testing. But to be honest, when I first met property-based testing, I wasn't too impressed. It was during my first months writing Scala a couple of years ago, where everything was new, different, challenging, hard, where I noticed that each new project that I join has those kind of thing called property tests. And at first I thought, oh, that's just another Scala thing. So I will get to do the same thing, but I will have to relearn to do it the Scala way. But when I took a good look and I learned what property-based testing really is about, I thought, wow, now that is pretty interesting. That really changes the game. And the reason why I thought that is that with property-based testing, you get to define some rules, some properties, but it's the role of the library to actually verify that rule for you and maybe find some bugs. So that's why I thought it's quite a revolution. But my second thought was, wait a minute, why am I learning about it just now? Why has nobody told me about it before? After all, you can easily apply it outside of Scala, outside of the functional world. So today, I would like to do just that. I would like to tell you that property-based testing exists, that it's pretty unique, and that if you haven't already, you might want to try it out. So let's start with an example. So let's say we are writing, we have our sample domain and we are writing a method to calculate a discount for the customer. So we have a method, it takes a customer, it takes a current date, and it returns a discount in the form of big decimal. And the algorithm which I won't show here is that if the customer is with us for less than a year, they get no discount. If they're with us for between 1 and 2 years, they get 10% discount, and if more than 2 years, they get 20% discount. And just to get things more complicated, let's say that if it's their birthday today, they get a special 30% discount only that day. So let's say, how would we go about testing such a method? If we were to do it traditionally, so as opposed to property-based testing, we can call traditional tests example-based tests. What I would normally do is I would start with a happy path. So I would prepare a test case saying that for the 10% discount, I would just prepare an instance of the customer who joined 1 year ago, invoke my method and verify that the discount is 10% or 0.1. And I would prepare a similar test case for 20% discount. So again, a customer who has joined 2 years ago and verify the discount. And then I would prepare another test case for the birthday discount. So similarly, an instance of customer who maybe joined just now, but it's their birthday today, verify that it's 30%. But of course, we know it's not enough. We have to think about edge cases. So what edge cases we could think of here? Let's say we want to verify that if the customer has joined just now and they have no birthday, they should get 0 discount. And maybe let's also make sure that if the customer is with us for a long time, they don't get some very large discount, but just 20% again. So if I did that, I would say, okay, I've got my algorithm tested, I've got the happy path tested, I've got the edge case tested, so it's all good. I can move on to another feature. So what's different if we think about properties here? So those properties are some kind of rules which you have to define, that you say that for your algorithm, no matter what input it has, the result is always has to follow this property. You define this property and the library tests it for you. So what kind of properties could we think of for our algorithm that we want to say that always has to be true for the result? We could say, for example, that no matter what the customer and current date is, the discount should never be lower than 0. And similarly, we could say that it should never be over 30%. So you might say, wait a minute, it doesn't really cover my algorithm in full. But that's really fine in the world of property-based testing. It's fine to specify a property which only tests some part of the algorithm. It verifies some aspect of the algorithm. Or you can think of it the way that it defines some safe boundaries, so that no matter what kind of input and surrounding there is, the end result is always within those safe boundaries. And that's what you test with property-based testing. What other properties we could have? We could test customers in pairs. So we could say in the test that if we have two customers and one of them has joined, is an older customer and one of them is a newer customer, then the discount for the older customer should be greater or equal than the one for the newer customer, so that it's proportional to membership years. Also, we could say that for two customers where one of them has a birthday, their discount needs to be higher or equal to any other customer discount. And those are properties which have to be always true. Now, how would we write such a property? How would a property-based test look like? So this is the test written for the property that the discount is not larger than 30%. And if you look at the body of the test, it looks pretty normal. So we invoke the algorithm, invoke our method, and we verify with an assertion that it's correct. So in our case, less than 0.3. But all the magic happens here in this for all. Because what happens here is the library generates a couple of pairs, 10 or 100 or 1,000, depending on the configuration, of various random customer and local dates, and verifies that the test still passes. I said random, but it's actually much more than random. It's something that I like to call nasty randomness or vicious randomness, because the library will actually try to find tricky data for you, data that will break your test. So for example, if we were working with strings, you would get for sure an empty string, very long string, string with various char sets, maybe with emojis inside, maybe with non-printable characters, to verify that your property is still valid, is still true, even for tricky data. So now what happens if for some of those cases the test fails? This test is written in Scala test, which uses Scala check underneath, but you can use any other property testing library for that, even in any other language, and all what I'm saying here would apply to it. So here, do you see what the problem was in my algorithm? It's the leap years. So actually my algorithm was throwing an exception for leap years because I did some calculations which didn't take it into account. And this is exactly the thing where property-based testing shines. Because when we write the code, we usually write it with a couple of concrete examples in mind. And we also write the tests with those examples in mind. So we are kind of biased. But the library isn't biased. It actually tries to find tricky data for us. So it's very good at finding bugs or areas where we haven't really thought through what the algorithm should be and how it should behave. Now, where does this generated data come from? Generally, for simple types, you will get generators or sample data out of the box. So for strings, lists, numbers, and so on, you will just get it from the library. But for your custom types, sometimes you will have to, and actually usually you will have to prepare your own generator, which is a recipe for what you mean by correct object that can be generated, prepared for the test. So here is a sample recipe for a customer, and you combine it from existing built-in generators that you have. So for example, alphabetic string, numbers, options from the predefined range, and so on. Or you can even use a generator that you have defined elsewhere. So such a for comprehension will give you and the library a recipe for what you mean by correct data. Because it's actually important to have your generators done right. Because if your property-based testing fails, you want to make sure that it isn't because it was given incorrect data in the first place. So then if it fails, you know that it's because of a bug in your method. So now if this property-based testing is such a great thing, then why aren't we already using it everywhere? And do we even need example traditional tests at all? Of course we do. And of course there are some challenges and some fine print. So let me tell you about the 3 challenges of property-based testing that I find the most important. The first one is that it makes you ask difficult questions earlier. So when I usually write code and I like to follow test-driven development, I like to write a very simple test case, then a very simple implementation, then a more complicated test case, more complicated implementation, think about edge cases and so on. But here, before you write your first line of test, you have to think about what is correct data for you, because you need to prepare the generator. So it means you have to ask questions like, what is the longest surname a person can have? What is the oldest customer we can have in our system? What is the maximum amount of money a person can spend on magazines a week? These are real questions from my experience that I had to go back to my product owner and ask them. So they would say, okay, you are thinking about edge cases, so you're probably already done, right? No, I'm actually starting. So that's something you have to get used to it. It changes a bit the dynamic of how you write tests. The second challenge is non-determinism. After all, it's some kind of random data. So it may well happen that you write your test, you run it in your computer, maybe a couple of times, and it passes every time. And then you push it somewhere to a Jenkins pipeline, and there it fails. What do you do about it? Well, for sure, what you don't do is you don't go to Jenkins, you don't rerun it and say that it's flaky data. No, you actually have to go investigate the logs and see for which specific test data the test has fails, because probably the library has found a bug for you. What do you do about that? Well, you can think of it this way. It's the test library which has found this specific bug for you, and not a client somewhere in production sometime from now. So you can think of it as a tool for finding the bugs before customers, real people and real data does it. The third challenge is coming up with properties. And it's the biggest of the challenges, in my opinion. Because here I have shown you what the properties can be for your method. But if you go to your real project tomorrow and you try to come up with properties, it can be difficult. Because how do you specify, how do you write something which has to be always true, but at the same time, you cannot just repeat the implementation? Because then if you have the bug there, then you have also a bug in the test. So you have to think of it in a different way. How do you work with this? You have to think of it as a kind of creative process, which means maybe you have to work with a colleague on this. Maybe you need to brainstorm ideas. Maybe you want to say to your colleague what your algorithm does in some different words, and then you discover the properties. Fortunately, there are also, the link below would direct you to a list of patterns. And that's a very helpful thing, to bookmark it and to go back to it whenever you are struggling with coming up with properties. So there you can go case by case, and there are some ideas of what properties could you think of. So for example, is it an invariant? Do you have an invariant in your algorithm? So something that doesn't change even after your algorithm runs? Or maybe you have symmetry, so maybe you are serializing and then deserializing, and you can compare the end result to the beginning. Or maybe you have a reference implementation somewhere so that you can compare your algorithm to some other algorithm which does the same thing but differently, and so on. So this list of patterns, I find it extremely helpful when I'm stuck and not creative thinking about properties. Now, if I say that property-based testing are so great, but they also are a bit challenging and hard to write, then what should you do? Should you go tomorrow, stop all your work on your features and just write property-based testing for everything? Of course not. And there are 2 strategies that I could recommend to you that you could start with properties. The first one is when you write a new piece of code, start with example-based tests first. So traditionally, maybe start from a simple test, simple implementation, more difficult test, or complex implementation. Then try to find on your own as many edge cases as you can, prepare example-based tests for them, and when you think you are done, only then start to think about properties. And it may well happen that you will discover some other edge cases, some other questions that haven't been asked about your feature, about your story. And then maybe you will have to go back to your product owner, ask difficult questions. So that's that makes it quite a nice journey through implementing your feature. And the second strategy is maybe you just need to provide the properties for your key components. What does it mean, key components? It may mean the most complicated logic that you have. Maybe for that kind of logic, you want to provide some safe boundaries, some properties. Maybe property-based tests will help you discover that you don't understand some of the code and you want to have some discussion about what it does. Or maybe key components means just the core code which does what your business does. So that you want to make sure that you do everything you can and invest resources to prove or try to verify that it's correct. And try to let the library find the bugs for you in the code that is really critical for what you do. To sum up, the property-based testing is something that comes as a higher cost. You need to think about it. You need to think about it in a different way. But in return, they give you the value that no other testing can give you. Where it shines is at discovering edge cases and misconceptions in the way you think about your code and your feature. The most challenging is coming up with properties, but it's also the most fun part, the most interesting part, and you will get better at it with experience. And the key, as usual, is to find the right balance. Because I cannot recommend any kind of ratio between example-based test and property-based test. But if you're for your own specific project, you find that ratio of confidence, it will give you the confidence that you have the code tested for the edge cases that you already know, and that you are some kind of prepared for some unknown edge cases that the library might discover for you. If you'd like to know more, there's a couple of resources about thinking about properties, coming up with properties, and this list of patterns that I mentioned that you might want to bookmark. And under this QR code and this link, you will find a link to the slides. And also, if you have some feedback or comments about the presentation, that's the right place. Thank you.
マグダさん、ありがとうございました。それでは質疑応答に移りたいと思います。もし質問がある方は挙手をお願いいたします。はい。真ん中の、はい。
Hi, thank you for the talk. You mentioned at the beginning test-driven development. Have you tried to do TDD only with property-based test? And how it compares, how does it compare with classical one with example-based?
Yeah, I think I have tried that, but for me it was not the right way because of what I said of trying to define everything at the same time. What is your algorithm? What should be the API of the algorithm? What should be the correct data? So I actually try to go the other strategy, the first strategy that I mentioned, so that you start first and then only later you think about properties.
Okay, thank you.
ありがとうございます。では、あと一人ぐらい。そちらお願いします。
Hi, thank you very much for the presentation. Super interesting. I really love property testing and we use it on our project. One of the problems we have with it is performance in terms of when we have a pipeline, CI/CD pipeline. We try to, before we merge, we run our tests. And these property-based tests are basically the same test running 100,000 whatever time, which creates a lot of slowdown. Do you have any recommendation, any hints, anything you can tell us about this kind of problem?
Yeah, so this is a problem that it makes your tests Maybe if you run it 10 times, it doesn't make you 10 times slower, but it does make it slower. And my recommendations are, I guess, simple. If you know that your test does something heavy, like call the database or write something to the files, maybe those tests you don't have to run 1,000 times, but maybe 10 times. Maybe you don't have to run it on every commit. Maybe you want to run it once a day or once a week. And for me, that's enough. Also, we can play around with the configuration of the test. So I think in Scala test, the default is 10, which I think is not enough, and you should raise it to 100 or 1,000. But for those heavy tests, you should keep it slower.
Thank you very much.
ありがとうございます。では、時間になりましたので、以上でセッションを終了させていただきます。では、もう一度拍手をお願いします。ありがとうございます。